Meet Skylar. Skylar likes lists. Checklists, specifically. Notes for her presentation. Check. Laptop, tablet, earbuds, and a book for the plane. Check. Of course, there are the things she doesn't need to remind herself to pack. Some can't be forgotten. At SAE International, we like lists too. Our lists are another kind of to-do. They're industry standards, and they're created by thousands of engineers and scientists worldwide. Our goal is simple: make transportation safe and efficient for sons and daughters, partners, husbands, wives, and mothers. For this mom who likes lists, SAE committees have created standards that optimize every aspect of the aircraft environment for safety. These industry standards mean that she can spend her flight rechecking her own lists and thinking about what's important.
Hey, Mark Z here. Welcome to Supercharged. I'm going to go in and check out some hot new cars here at the Hyundai in southeastern Michigan. And then from there, we're going to head all the way to California and check out some new technology with Michael Porter at their headquarters out in California. Welcome to Supercharged. Today we have another special guest with us out in California, actually. Mike Porter is out at the Hyundai Motor America office in California, and he's going to talk to us about new vehicle tech. So welcome to the show, Mike.
Hey, good morning. How you doing?
Yeah, it's morning to you, and it's,
Oh,
I think, a little afternoon here. But it's all good, and it's all good everywhere. So it's great to see you. Thanks for joining us. I know we chatted a little earlier, and got some really neat technology that coming along. I really like the styling too. The new vehicle stuff, it really catches my eye. So
yeah.
as an engineer, we like the techie stuff, but it doesn't hurt that your cars look pretty good too.
Yeah. Yeah. Well, and I'll get into this in the presentation, but some of the styling is tech stuff. It's not all just how it looks. So I'll get into that later, but yeah, very excited to be here.
Great. Well, why don't we just get right into it? And if you want to just give us the idea of what is the new tech coming down. So uh,
Yeah. So I'll get started here with our kind of cream of the crop, which is our Ioniq 5N. So this is kind of what we would consider our halo car. So this is, our one of our fastest vehicles. Or it is our fastest vehicle. And you might hear this refer me to its internal code name as NEN. If I do that, I apologize. Just know that I'm talking about this vehicle. So yeah, let's get right into it. We have a dual motor setup. They're both IP MSMs, interior permanent magnet synchronous motors, and we get some benefits with that, which is a higher efficiency than a traditional surface PMSM. So that's why we went that route. We also have, some fairly common tech nowadays, but was new tech maybe, 10 years ago. Hairpin motor windings, lower weight because fewer magnets are required. And these are oil cooled, so you can actually do an oil change on your EV.
hey, all right. Can't wait to try.
Um, yeah, so not many people think about that, but yeah, they are oil cooled. More highlights here. I've got some of these shown here. So we've got 641 available horsepower. that comes with a boost function, which is available for 10 seconds at a time. And we have a nominal voltage of 697 volts. So this is what we think of when we think of 800-volt architecture. And that allows us to have ultra fast charging. So 10 to 80% in 18 minutes, which is, gets you about 200 miles of range in that time.
Yeah, that's so great.
Yeah. So, it's all of these little things that we put together to create something that's, fun to drive, but also usable as a vehicle. I've had to do a longer-ish drives in these, and I never really thought about charging. So it's good from that perspective. You can see that the output, 641 horsepower, is 478 kilowatts, but our battery output is 535 kilowatts. So this is higher than the power draw of the motors, so that we're not pushing that battery at its maximum output. And that gives us a couple of benefits. One is we can run some cooling on it, but then also because we're not pushing it at its maximum, we're not heating that battery as fast as we could potentially be heating it. So yeah, battery tech, motor tech, all of that has to work in combination with each other.
Mm-hmm.
Continuing with that, going into the powertrain a little bit, we do have a very, very mildly higher rear drive ratio than front drive ratio. And that induces a yaw moment at the rear of the vehicle. So what that does is it reduces the understeer, provides better turn in, and it makes the rear tires do some of the work during turning. And I know that seems counterintuitive, but it allows the vehicle to rotate a little bit as those rear tires try to kind of slide out a little bit. So what that does is that gives us the ability to rotate the vehicle through a corner quicker. So again, we wanted to create a vehicle that's usable, but we wanted to create a vehicle that's fun as well. And then right here, just something to laugh about again, is the oil fill capacity for the front and rear motors. We also made some pretty dramatic improvements to the body in white. So we have an extra 42 additional welding points and 2.1 meters of additional adhesives over the standard Ioniq 5. So the standard Ioniq 5 doesn't have the same motors in it, and these motors are a little bit heavier. We reinforced the frame body in white by pretty significantly. In this diagram here, you can see where we're using mild steel, high strength steel, which is most of the chassis, and then ultra high strength steel in some of those crash zones where you need that extra protection. And then that also gives us some better lateral rigidity as well in the chassis. One of the things that we did on this vehicle, this is actually something that Hyundai has been doing for a while now, but this is the first vehicle to have it front and rear. It's typically just been in the rear, but we have something called an integrated drive axle. And so what that does is it integrates the wheel hub and the drive axle on the half shaft. So if you can see that top picture, you have what you typically would see on a vehicle, where you have the wheel bearing and then you have the half shaft or the drive shaft, coming from, either the motor, or maybe it's the differential, or, whatever it is feeding power there. It's two separate components. And so ours is now an integrated drive axle, which combines those two components in that bottom picture. So some numbers to throw at you: stiffness increased by 42%, weight decreased by 10%. So we're using those front and rear. We've been using that, like I said, in the rear of the Ioniq 5 since it came out, but this is the first vehicle that we have using it front and rear. So that's pretty cool. We also, over the regular standard Ioniq 5, we strengthened the steering system. So we have a specially tuned NR-MDPS is what it's called. So it's a rack-mounted power-driven power steering, rack-mounted motor-driven power steering. Steering ratio. So there's two kind of main systems that OEMs are using now. There's rack mounted and column mounted. And of course, we went with the rack mounted motor to keep weight lower in the vehicle. So again, wanted to build a car that's fun. So we have something called the N-Drift Optimizer, which we do not approve for use on city street. But so what that
with
does,
that.
yeah, but what that does is it monitors the yaw angle, and it maintains that angle using front and rear motor torque differential. So basically, by changing the amount of power or torque we're sending to the front and rear motors, we're able to maintain a drift angle based on the driver's steering input. This is something that, because we're using electric motors, is something that we can do fairly easily. Whereas if you were to try to do this in, we think about like people that traditionally will spin out a Mustang. Again, that's a rear wheel drive. This is all wheel drive, but the concept's kind of the same, right? Where it's very hard to control that with a gas powered motor. You just don't have that fine tunability that you have with an electric traction motor.
Did you help calibrate this one, I hope?
Yeah. So, some of the other things that we added as part of this, there's a torque kick feature, which is basically simulating a clutch kick. And so that sends that jolt of torque to the rear wheels to start that slide, that yaw moment. So yeah, really a really cool feature, really, really fun feature. Again, not for use on public roads, but I think you probably knew that before I said it. And then we get, some into the nitty gritty. So, this is our diagram for how we're cooling our motors, our traction motors, and our battery. So we have a heater and a chiller for the battery, because you want the battery to be in a temperature range, right? So we put the battery in a certain range, but then if we choose to select something called N-race, it allows that battery to raise that temperature a little bit. So if it's really cold out, we'll use the heater. If it's not cold out, we'll let it warm up automatically. But that will provide more power from the pack, but it comes with the risk of degrading the battery, right? So as the temperature goes higher, you have a higher risk of degrading the battery. So we only do this when we're asked to do this. When a driver is asking us, I need everything this car is capable of, we'll let the pack temperature go higher. When it's not what we're doing on a regular basis. So we can see here in this diagram, pretty much everything is cooled, right? So we have a water cooling for both motors, and then we also have the battery chiller. So again, batteries like to be at, we call it room temperature, right? They like to be somewhere around room temperature. And the further you stray from that, the worse it performs. Sort of like people, right? You ask people to run in 100-degree heat, we perform worse. And so that N-race lets us raise that temperature. It gives us a little bit more performance, but again, with the risk of degrading the battery. We have some pretty significant thermal management going on this vehicle. So we have much more airflow. You can see I've compared a standard Ioniq 5 to the Ioniq 5N or the NEN. You can see up top here, there's this grill that looks like it's just decorative, but that's actually for airflow into the radiators. And that's a dual radiator setup because we just needed more cooling. The dual radiators, they're both larger and they assist in keeping the temperatures cool. Because again, we know we're creating a lot of heat by creating 438 kilowatts of power at a time. So we also provide an in-cabin display for the battery and the motor temperatures so that the driver can see, what's heating up, what's not heating up. If you're really looking at like the race aspect of this, you can know, how much front motor heat is being generated, how much rear motor heat is being generated, and you can adjust your driving style based on that so that you can hopefully maintain your temperatures correctly. And again, so we're going to go back to the battery really quickly, talking about cooling and that sort of thing. We have something called battery preconditioning. And again, this goes back to the fact that batteries like to be at that room test where they maybe not get the best performance, but that's where they have the most stability. And when we charge the battery at our 800 volts, our 10 to 80 in 18 minutes, right? We need that battery to be a little bit warmer. So we have something called battery preconditioning that allows us to charge. But then it gives us two other modes, which we're calling drag and track. So track lets the battery heat up a little bit further, and then drag lets the battery heat up even further past that. So drag would be used for like a drag pull, where it's one pull. We're not doing this for an extended period of time, but we want to get the absolute maximum performance out of the pack at that time. And then track is for, it's kind of a happy medium, right? It's between optimized for longevity and complete power. It's optimized basically for an increased number of laps if you were to be on a racetrack. On a racetrack, you still want a lot of power, but in drag mode, maybe you get that for 1 lap, whereas in track mode, you would get that for 6 or 7 laps. So we're giving the user the ability to say, this is what I need from this vehicle. So let me select what I need. Now, I've driven this car quite a bit, and even without putting the battery in any of these modes, there's plenty of power. I mean, there's plenty of power. In your day-to-day use, you're never using this. But because we wanted to create something that's a track-focused vehicle, this is, stuff that we're adding to it.
Even more fun with your car.
Exactly.
Yeah.
And, you don't need this for your day-to-day drive, but you don't need a Ferrari for your day-to-day drive either. And, so that's the kind of mentality, is you don't need it for your day-to-day drive, but someday you might. And then here's kind of a diagram of our charging. So we always charge the pack at 800 volts. The pack doesn't do any sort of up conversion to 800 volts or anything. All of that's done off board outside of the pack. This is something that got a lot of attention from journalists. It's called our NE shift. And so what that does is it simulates the gear shifts of a dual clutch transmission. So we base that off of our dual clutch transmission, our Elantra N, and it takes a bunch of different information. So vehicle speed, accelerator pedal, brake pedal, shift lever, meaning drive or reverse, and then battery information, charge, power, and it puts that all into the VCU. And when you're accelerating, as soon as it gets to a simulated red line, it will cut torque for just a second and then continue it. And it feels very much so like it's shifting gears. And that's done in combination with what we're calling our N Active Sound Plus. So there's 8 speakers inside the vehicle. There's 2 speakers outside the vehicle that simulate our Elantra N, our 2-liter turbo engine in that vehicle. There's a couple other sounds you can choose, but we're basing it off of the Elantra N 2-liter turbo. And it will give you the sound as if you were driving a gas-powered vehicle. It does that in the cabin, it does that out of the cabin, and it's very convincing. It's very, very convincing. I drove this vehicle for about a month, and maybe twice when I was using it, I was like, oh, that wasn't a real shift. But every other time, 99.98% of the time, it was like, no, I really feel like I'm driving a gas-powered vehicle. It was very, very convincing. So well done to the team of engineers that was working on that. There's 2 more functions that we control with the VCU. So we have a torque distribution function, and it offers a fully variable front and rear torque distribution. So it's adjustable on the screen via an 11-stage menu. So you can go from 100% front to 100% rear and anything in between in 10% increments. And then the VCU also controls our launch control. So the way standard launch control works is by optimizing the power output to mu, or the coefficient of friction between the tires and the road surface. We added a second, kind of an extra thing there where there's a user selectable traction level. So we have, low, medium, high as the available traction that the user believes is there. And when they choose that low, medium, or high, what it does is, instead of the VCU having to determine, here's a much wider range of potential coefficient of friction between tires and the road surface, it's now saying, okay, I can look at a smaller range, which means that it's more accurate and it'll allow for more power quicker. And so, there's user selectable options for launch control. In the front, we have some active air flaps. It reduces our coefficient of drag. If we close those flaps, it reduces our coefficient of drag. We also have air curtains over the wheels. This is similar to, you think about some older vehicles had covered rear wheels. But those have some pretty significant drawbacks. Air gets trapped in the wheel arch, heat gets trapped in the wheel arch, especially under heavy braking events. So we used air curtains, which just basically create that covered rear wheel effect with fast moving air. Rear diffuser helps with our decreased coefficient of lift and decreased coefficient of drag as well. And then the wing type spoiler decreases our coefficient of lift. Basically, both of those create downforce. On our wheels, we have 5, we call them accent caps, that help with aerodynamics, but those can be removed for maximum brake cooling. So if you're really beating this car on a track and you need all the brake cooling you can get, those can be removed. And they can also be removed for service as well. We also have something called end pedal, which is our deceleration rate. We have a deceleration rate of 0.6 Gs just from lifting off the pedal, which is, it's huge. It's more than you will probably ever need in day-to-day driving. And that allows for more weight transfer to the front axle as you come off the accelerator. As you come off the accelerator, right, all that weight transfers to the front, gives you a little bit more grip for turn into a corner. Most regen braking is done with efficiency in mind, because we want to transfer the most energy from, the movement of the vehicle back into the pack. But end pedal deprioritizes efficiency and prioritizes maximum braking performance from a regen. And then here's kind of the future, right? So we have the RN24 there on the right, and then the Envision 74 and the RN22E. We just released our Ioniq 6N, not to the public, but we just released the information about it. And that's kind of where this is going. So when we can talk about it, we'll talk about that. But for now, we just released that it's coming. But all of that technology is going to be based off of stuff that we've improved from the Ioniq 5N. Yeah, and so then that's it for the the most fun cars. We've got some other
family
vehicles.
Cars, but they're still fun.
And realistically, these are going to be our Halo cars as well, right? So this is a 3-row, pretty. I mean, if you stand next to a pretty strikingly large EV. We had a vehicle that we got about 350 miles of range out of, just driving around and around. That's just me and my team. So I know PR has their, how much range it gets. They're going to tell you whatever it is, but realistically, the range is very, very impressive. It comes from a 110 kilowatt hour battery pack. It's a very large battery pack, but impressive nonetheless. There's some new things that we introduced with this vehicle, feature on demand, which is where the user can go in and choose to customize their vehicle. This is more like a proof of concept. That'll be more implemented in later vehicles, as you'll see here in just a minute. This vehicle comes with remote smart parking assist too. So it can do parallel parking. A lot of people don't like to parallel park. Well, here you go. We'll parallel park for you.
Hit the button.
Then we've got our Palisade. This is also kind of considered our Halo vehicles. It's nicknamed the LX3. Comes with a dash cam. So that built-in dash cam can be accessed through either Wi-Fi or cellular data or a micro SD jack. All of that can be fed to different areas in the vehicle. So you can look at your dash cam while you're in the vehicle. You can look at it on your app. You can look at it, on a computer with an SD card later if you'd like. We also have a rear HVAC. So the second and third rows get their own dedicated HVAC blower motor. So, you can have the AC running in the front. You don't have to have the AC running in the back. And what this also does is it allows the rear passengers to have a shorter distance between them and the HVAC. And so, when we're talking about a third row on a vehicle, a lot of times when the air conditioning gets back there, it's not quite as cold as it really needs to be. And so, if you have people that are kind of squished back there, it's getting a little hot, this is the solution, right? We put a new HVAC into the rear. When you open the trunk, it's on the left. So that's one more thing. And then we introduced a Hyundai Digital Key 2.0 Premium. So this is your phone can be used as a key. It interacts with all of these different sensors on the vehicle. And once, the vehicle authenticates your phone, you're able to use your phone as a key, never have to use another key again. I've been using this on some other vehicles for quite some time, and I don't carry a key.
Yeah, very handy.
It's just easy, right? So, and then here's something that's really, really cool. So safety is obviously a big concern with any three-row SUV, right? You're probably putting kids in the back. And so we have third row pretensioners for the seatbelts, which is something that traditionally is only seen on the front two rows. And then we also have load limiters. And so load limiters, again, traditionally only seen on the front two seats, but that's now in the third seat. And I'll just talk about this for a second because I really like how these load limiters work. But basically, when it recognizes that there's a substantial force on the seatbelt, it'll allow it to slip out just a little bit so that we avoid any major bodily injury to the passenger, which is, is not something you really think about. You think about seatbelts saving lives, but you don't think about seatbelts potentially injuring people. And so these load limiters, traditionally found in the front two rows are now all the way into the third row. And then we've got full length side curtain airbags as well. So in this diagram here, you can see it goes all the way to the back where that third window is. So really cool stuff. Occupant detection. We use radars in the headliner. Those radars are looking down. So when you lock the door, if it senses movement, it can tell you, hey, you left a child, you left a dog, you left a, whatever in the vehicle. So all very, very cool stuff. And yeah, that's what's new at Hyundai.
Man, oh man, you guys been busy.
Yeah, we have.
Yeah, and
We have.
great engineering too, and to go along with that style and the great technology. Really appreciate you sharing that with us, Mike. It's great to learn right from the source and give us that engineering insight while you're talking here. One of the things that I was thinking about is with all that technology, there's probably a lot of repair techniques and tools that repair shops and dealerships need, but we'll have to get into that at a later time. It's there's a lot more to the vehicle lifestyle, lifetime, and besides styling and technology. But you guys are on top of it, so it's fantastic.
Yeah,
Well,
well, we're very excited to be, bringing stuff to consumers, and yeah, like you said, we'll talk some more about, diagnostics, and diagnostics is my area, so
yeah.
uh,
Well,
we'll talk more about that later. But yeah, very, very happy to be able to bring this stuff to
well,
consumers.
thanks. One last question. I know our viewers are probably wondering, what's the, how much is this end vehicle going to cost me? I got to have one. I got to talk my wife into one. How much is that
Yeah.
going to cost?
So it's around 70,000. I don't know the exact number for
Uh-huh.
NEN. I'm not sure what the Ioniq 6N is going to cost. I
Yeah.
don't think we've set pricing for that.
Uh,
And if we have, we definitely haven't released it. Yeah, it's around 70,000, which is, I mean, I know people are thinking that's a
yeah.
lot for a Hyundai. And you're right, that is a lot for a Hyundai. But when you have, the tech and the driving experience that that vehicle has. I come from a long line of liking to drive fast, and I was very, very happy with driving that vehicle for a month. I was overjoyed. I don't
Fun
know how much my passengers liked it, but I
job.
was thrilled.
A fun job. Well,
Yeah,
again, thanks for joining us. I really appreciate your time, and our viewers do too, from all of us at SAE and the Detroit section. We're grateful to have you and your company share this technology with us. So thanks again, and I wish everybody out there a supercharged day, everybody. Have a good one.
thanks for having me.